All right, let's talk about perimeter. Now, in your readings, you were given some formulas for perimeter, and I really wouldn't stress those formulas too much. It's more important to know the actual definition. To keep in mind that when we're thinking about perimeter, all it's really saying, no matter which formula you look at, is take the sum or add all the sides. That's all the perimeter is you don't really need any sort of fancy formula. Just make sure you know to add all the sides up. So for instance, in this first example of a trapezoid, if I want to find the perimeter, I would usually just start off and I try to identify which one I'm starting at so I don't double count or forget. And say I'm going to add 14, and then I'm just going to go counterclockwise around. I'm going to add 14, 23, the other 14, and the 37 together. And so once I realize that's what I'm adding together, I'm just going to grab my calculator out, and I'm going to say 14 plus 23 plus 14 plus 37 is 88. And that's it. Now, as far as our units are concerned, this is going to be a linear unit. By linear, I mean only to the first power. It's just inches. It's not square inches or cubic inches or anything like that. We're measuring inches. Make sure all the units match up. And since they do, this is 88 inches. Now, if we look at the next example of perimeter, this is a little bit more of a complicated figure. And also, not all the values are given to us. So this becomes a little bit trickier. But we can figure out what those missing values are fairly easily. If we realize that the entire width of our shape is going to be the sum of those values there, then we should be able to easily see that, hey, if the entire width is 13 feet, and up top I've got 6 feet, then that other missing measurement had better be 7 feet. To find the other missing measurement, we could use similar reasoning to say the entire height is 17 feet. We have 4 feet there. And so what are we missing? We're missing 13 feet there. So that measurement's 13. And all of a sudden, we should have our values. Let me go ahead and rewrite those so it's clear what they're representing, that this guy here is the 13. And this one here is the 7. And so I can do the same thing I did in the last example and say, hey, let's start somewhere. Let's start at the 4, and let's just work counterclockwise. I've got a 7, then a 13, then a 6, and a 17, and another 13. I know I'd start at the 4, so I've got everything covered. So now I bring my calculator back out, and I've got 4 plus 7 plus 13 plus 6. Oops, wrong button. We'll fix that. So that was supposed to be plus 17 plus 13 adds up to 60. All of these were in feet, and so 60 feet is the perimeter. Now, one of the things that we will see sometimes is you'll be given the perimeter, but you're asked to find some missing value in the problem. If that happens, replace the missing value with a variable, and then you can write an equation that represents the perimeter, and then you can just solve for the variable. So that, for instance, we've got this perimeter of a rectangle being 32 feet, where one side is 6 feet, and we don't know what the other side is. So I would draw a picture, first of all, and say, all right, one of the sides is 6. Now, we could use the perimeter formula, but as I said before, we should just kind of know what the perimeter is by adding everything up. And say if this is a rectangle, this other side is 6. The missing side, we're going to make it a variable. We'll call it x. And the other one is x2. And so if we find the perimeter by starting here at this number and adding up the x plus the other 6 plus the other x, to make an equation, we can say when I add all those up, I'm going to get 32. I'm going to get the perimeter. And now we can solve this equation. On the left side, we can combine our like terms. We have an x plus another x is 2x. 6 plus 6 is 12 equals 32. Then we can solve this equation by subtracting 12 from each side and then dividing by 2. And we can see that the other missing side length then is 10. So we're not going to say x equals 10 because we made up the variable x. We're just going to say, hey, it's 10 feet. 10 feet is missing side. And then we can even check our answer. We could plug in the 10 into our picture and say, hey, if I had 10 plus 10 is 20, plus 6 is 26, plus the other 6 is 32, hey, that works out. It's perfect. Now we're going to talk about circumference. Circumference is just a fancy word for the perimeter of a circle. We don't call it the perimeter because the perimeter is kind of defined by going from each corner or each vertex to the next. And with a circle, there aren't corners. There's not vertices. It's just one big old circle around. And so that's why we call it circumference. We give it a different name, but really it's the same idea as perimeter. It's just the distance around the outside. Now, here's a little experiment that you can do around your house to help you understand some of the things involved in this formula. Take anything that's circular around your house. Whether it's a tire, you can take a soup can around the outside. If you got a basketball hoop, you could use that. Anything circular that you have laying around the house. You could take a string and put that string around the circular part of it, and then you can figure out how long that is or what the circumference is. Now, with that same circle, measure the distance straight across from one side to the other. So if you're using a soup can, go from one edge to the other so you're kind of going through the middle of it. So you're basically taking the biggest possible length across. If you divide those two numbers, no matter what circle you took, you're going to get the number pi, which you've probably seen before, is about 3.1415. It goes on forever. It's an irrational number. But if you take the circumference and divide by the diameter of any circle in the world, you'll always get this number pi. And that's why we gave it a special name. So we gave it a special name because it kept coming up all the time. And so pi is the ratio of the circumference to the diameter. Now, if we just multiplied both sides of that equation by d, we'd get a formula for circumference then. Circumference is pi times the diameter. Now we know that diameter is 2 times the radius of a circle. The radius is the distance from the middle to the outside, so the diameter is 2 of those. So another variation to the circumference formula is circumference equals 2 pi r. You can really use either formula you want, whichever one's easier for the problem you're working with. So if you're given diameter, use pi times diameter. If you're given the radius, it's pi times 2 times the radius. So suppose we want to find a circle that's got a radius of 4 centimeters. Well, if that's the case, I would use the formula circumference equals 2 pi r, at which point the r is 4, so it's just 2 pi times 4, or 8 pi. And if we want to figure out what that is approximately, we can use our calculator. And we can say 8 pi. Pi is actually a button right on our calculator. And this is one of those situations where like, yeah, thanks, stupid calculator. It's 8 pi. We can hit the button right above enter and we can get an approximation. So this is going to give us 25.13 is the circumference of this particular circle. Now let's take a look at this circumference here, where we're not straight up given any information besides a picture. This is a little bit trickier sometimes. Sometimes it might be easier. So the center is not exactly given to us, so what I would look at if I were you is either the lowest point or the furthest point to the left. And this is going to help us define either our diameter or our circumference. So our lowest point is right here. If we look at the highest point, it's right there. So we can see that we've gone up by 2, 4, 6. This tells me the diameter is 6. This allows me to find the circumference then. I could use pi times diameter, so circumference of 6 pi. I could then grab my calculator and say if I got 6 pi, and I want to turn that into a decimal, it's about 18.85. Now you could have tried to find the circumference by finding the center as well, where we can see the center is right there. And then we could try to find the distance in either direction and say, oh, that distance there is 2, and then one more is 3, or the distance there is 3, or the distance there is 3, or the distance there is 3. So that's another option you could have taken, but I think the diameter option was probably the easiest.